All right, so in this lesson, we're going to be talking about absolute value equations. You probably have dealt with them in the past before, but you've probably never, obviously, done it with in terms of graphing. So you may know what the graph looks like. Again, all the examples are here on the title page. But just like with exponential equations, with quadratic equations, there's certain vertical and horizontal shifts that we have to deal with. And so we're going to talk about those today, and again, kind of overview what absolute value is. Now again, some of you might remember absolute value because absolute value equations are always quote-unquote positive, which isn't always true, but the adage is, again, it's not necessarily, it's positive, it's the distance away from zero, if it's a true absolute value equation. So, and notice all the pictures here. Again, let me just show you the next picture, why not? Okay. So, notice how it's at 0, 0, and both lines are going up. Because at absolute value of x, if I plugged in 1, it equals 1. But if I plug in negative 1, again, the absolute value of negative 1 is still positive 1. So those are all, again, it all kind of follows the same suit. And it's not that they're always going to be positive, but an absolute value graph means it doesn't matter if it's positive or negative, it's still going to be that same answer. So if it doesn't matter if it's negative 1 or positive 1, the answer is still going to be 1. So, and the other important key feature to notice here is that, notice how the graph, it has a corner right here at the vertex of what we call, that's the vertex, also called on the absolute value graph. It's a corner. It doesn't curve like a parabola does. It literally just hits and then immediately takes off to the next side. And so it really is a quick cut. It's not a rounded edge. It's a very jagged and cornered edge. Okay? And another key feature I need you guys to notice about this is that, again, if you were to count the slope of one of the lines, it would go up 1 over 1, up 1 over 1, up 1 over 1. So it has a slope of 1. And we write the slope of the line in front of the absolute value. But in this case, we don't have to write the 1 because it's already there for us. Okay? So those are all the things that you should know before we get into it. Now, as you guys already know, we have vertical movements, and notice how, again, it's on the outside of x. So it's kind of like when we had a quadratic equation, it was y equals x squared plus 9. Okay, so that plus 9 represents a vertical shift up 9. Same thing if I were to do y equals like 2 to the t power plus 9. Again, that plus 9 is a vertical shift, and that's when something is added to the function, it represents a vertical shift. So here, the minus 2 is a vertical shift. Here, the plus 2 is a vertical shift. So that's how that works. Now, let me show you on a graph what that looks like. Okay? Whoops. All right, so if I were to graph this, again, I'll do it kind of quickly because I think you guys get the idea. Okay? So this is what a regular absolute graph would look like. Right? Again, it just kind of V's up and has a harsh corner. But then this minus 4 means I go down 4. 1, 2, 3, 4. So my vertex will be there. And my new graph will just do this. Okay? So the equation y equals the absolute value of x minus 4. It's the red equation there. Again, it's just a vertical shift down. So for the absolute value of x plus 3, again, it would normally start here at 0, 0, but the plus 3 means it's a vertical shift up, so 1, 2, 3. So same graph, just 3 units up. Okay? So again, you guys know vertical shifts, that's not that too bad. All right, then we have horizontal movements. And just like with parabolas and just like with exponential equations, remember when I had something like y equals, again, 2 to the x minus 2. So remember that, again, when it's with x, that means that's a horizontal shift or a left and right switch. But you do the opposite of what's in what it says. So if it says minus 2, our inclination is to go to the left 2. But really, we do the opposite. We go to the right 2. Same thing with quadratics. If I had x plus 3 squared minus 5, the plus 3 in with x tells me that the there's a horizontal shift, but we do the opposite of what it says. We actually go to the left 3, not to the right 3. So you'll notice it's x minus 2, so we'd actually go to the right 2, because we do the opposite. And here it says plus 2, so that means we go to the left 2. So with horizontal shifts, we do the opposite. With vertical shifts, we do what it says. So in these problems, again, x plus 4, again, if I just have my general absolute value equation, and then I did plus 4, again, that means I actually go to the left 4. So 1, 2, 3, 4. Okay, so we do the opposite. So my graph would actually look like this. So all you did was move to the left 4. And then for minus 1, and again, let's go ahead and make what a regular absolute value equation would look like. And if it says minus 1, we actually do the opposite of what it says. So that means I should go this way 1. So my new vertex would be here, and it'd be like that. So there is horizontal shifts, vertical shifts for absolute value graphs. Now, what if you had to put both of them together? Not a big deal. Okay? So normally, you'd start here at 0, 0, no big deal. Okay? But then I see that I have a vertical shift. I have to go up 5. And then I also see I have a horizontal shift, and I do the opposite rather than going to the left because it's negative. I go to the right 4. So I go up 5, 1, 2, 3, 4, 5, over 4, 1, 2, 3, 4. Again, I'm just making up lines here. So there's my new vertex, and then from there, I make my absolute value graph. Okay? So not so bad. All right, and here's a couple of other little quirky things we need to look out for. Okay? There's the negative in front. So the negative in front changes everything. So normally, where, again, if we were to draw my regular graph, okay, here at 0, 0, okay, I do notice that I have a vertical shift, so I go up 1. But I also have a horizontal shift, but I do the opposite of the negative, so I actually go to the right 1. Okay, so my vertex is going to go up 1 to the right 1, so it's going to be here, but the negative tells me it's actually going to face down. Okay, so just like a parabola, remember if A was positive, it's happy, it goes up. When A is negative, it goes down. So that's the big change there. And then there's one other little thing, okay? We can go backwards. If I give you the graph, you should be able to know what the equation is. Okay? So first thing we do, let's find the vertex. Okay? Vertex is at 0, comma, negative 3. Okay? So again, that's my horizontal shift, right, because x. And this is my vertical shift, negative 3. Okay? So when I write my equation, it's y equals absolute value of x. And because there's no horizontal shift, I don't have to put plus 0. But I guess you can if you want to, but I won't. Okay, so absolute value of x, vertical shift minus 3. Okay. Then, here's the other important thing. Remember I told you about the slope earlier? It comes in handy here. So notice in this graph, it looks like it goes up 2 over 1, up 2 over 1. So my slope is actually a positive 2. So my absolute value graph, or the equation is 2 absolute value of x minus 3. So remember, the number in front of the absolute value is the slope. If there's any horizontal shift, it goes with x. If there's any vertical shift, you write it as is on the outside. So there you go. There's absolute value. Go ahead and do the quiz, and I'll see you guys tomorrow.